solve the problems in utility theory for decision making on each of the following three methods. First method, von Neumann and Morgenstern method. Second method, standard gambling technique. Third method, logarithmic utility equation.
Let us understand the concept of utility. When there are preferences other than money, then the utility term is used. Now suppose we have number of alternatives. Then how to select the preferences for these alternatives? Then we have to assign some utility value to all these alternatives, and the utility means the measure of preference. Then according to that utility value, we have to select the preferences for these alternatives. Then this utility depends on our attitude of accepting risk. There are three types of curves, and these curves are known as utility curve or utility function. That means there are three types of curves for the three attitudes of a person. So the person is risk avoider, person may be risk neutral, or person may be risk taker. So according to the attitude of the person, there are three types of curves, and this curve when we plot for a given question, then only we can decide according to the slope of curve which type of decision maker is there. Now the first curve, if we observe, this curve is utility measure versus money. Now if we observe, as the money value increases, the slope is decreases. That this curve is followed by a risk avoider. Now the second type of curve, utility measure, is directly proportional to the money value. So when a person thinks that every rupee is equally important, then the curve is followed by that person, and this is the realistic form of curve, and it is followed by a risk neutral person. Then this is the third type of curve, the slope increases as the money value increases. So here this curve is followed by a person who is risk taker. There are three methods to measure the utility. First method is von Neumann and Morgenstern method. In this method, two alternatives are given. First alternative, sure gift of rupees 1200. That is the chances of getting rupees 1200 with probability 1. And second alternative, winning rupees 5000 with probability 0.5. So there are two options, that is either winning or losing. So losing, that means he will get the rupees 0 with remaining probability, that is 1 minus 0.5. That is the other chance is that rupees 0 with probability 0.5. Now it is also given that the person is indifferent to two alternatives. That means he is okay with either he will get rupees 1200 with probability 1, or he is also okay with he will get rupees 5000 with probability 0.5, or he will get rupees 0 with probability 0.5. That means the chances of winning and chances of losing is half-half. So person is indifferent to these two alternatives. Then this point is called certainty monetary equivalent, that is CME. So when this point is there, that is certainty monetary equivalent, then we can write here one equation regarding utility. Now if we observe these two alternatives, there are three outcomes, that is rupees 1200, then second one is rupees 5000, and third one is rupees 0. Now we have to assign some utility values. So assign arbitrary utility values to the outcomes. Now we have to assign these values to two outcomes. So we will select here the maximum outcome and minimum outcome. So maximum outcome is 5000 and minimum outcome is 0. So we can assign any utility value. So either for this utility 5000 we can assign value 5, we can assign value 10, or we can assign value 100. So here we will assign here utility 5000 is equal to 5, and utility 0 we will assign the minimum value. So for maximum outcome we have to assign maximum value, and for minimum outcome we have to assign minimum value. So minimum value is 0, and maximum value we can assign any value, either 5, 10 or 100. So here we will assign 5. Then because this point is certainty monetary equivalent, because person is indifferent to these two alternatives, we can write here equation in terms of utility. Now he is having the same alternatives. For him these two alternatives are same. He is indifferent, so we can write here this utility of rupees 1200 with probability 1 is equal to utility of this 5000 with probability 0.5 plus utility of this rupees 0 with probability 0.5. So how we can write? Utility of 1200 into 1 is the probability for this, because this is the sure gift, is equal to 0.5 utility 5000 plus 0.5 utility 0. Now we will put the values of utility 5000 and utility 0. That is 0.5 into 5 plus 0.5 into 0. So when we solve this, we will get utility of 1200 is equal to 2.5. So this is the method to solve the questions for the two alternatives given by the first method. Now we will move to the second method. So second method is known as standard gambling technique. So this technique is also applicable for such a type of alternatives. Now we will assign some letters to these alternatives. So first we will take here the rupees 5000. So rupees 5000 we will assign here letter A. Then rupees 0 we will assign here letter C, and for rupees 1200 we will assign the letter B. So B is equal to 1200. Now what is happening in this question? The probability for these values, that is A and C, is getting changed in such a way that the person will become indifferent to in between these two alternatives. So here probability of winning and probability of losing we have to change in such a way that utility of B is equal to utility of A multiplied by probability plus utility of C multiplied by 1 minus P. So what is the relation in between winning and losing? So suppose for winning having probability P, then for losing having probability 1 minus P. So we have to change, by the second method we have to change these probabilities so that this person will get the indifferent in between these three values, that is A, B and C. So how we can write this equation? So we can write this equation UB is equal to, that is UB is for first alternative, is equal to P multiplied by UA. So this is the value A plus 1 minus P UC. That means we can say that therefore U1200, now here probability is 1, so we can mention here 1. So it is always 1 because this is sure, which is equal to P into U5000 plus 1 minus P into U0. Third method is logarithmic utility equation. Now we know that this utility curve here, the slope is getting decreased as the money value increases, and this type of slope is followed by the risk avoider. For this slope we can write the equation Ux is equal to log of x plus 1, where x is monetary amount. Now we are going to solve the three problems based on each of the three utility methods.
Now we will read the first question, which is based on von Neumann and Morgenstern method. A businessman is thinking whether to invest in bonds with an assured return or in a new venture that is likely to fetch him rupees 20,000 or nothing with equal probabilities. The businessman says he would prefer a assured return if it is rupees 10,000 or more, would be indifferent to the two alternatives if the assured return is rupees 8,000, and would opt for the risky alternative if this amount is less than 6,000. The businessman had purchased minicomputer last year, which is lying with him unused at present. The minicomputer can fetch him a profit of rupees 8,000 by way of consultancy. He says that he would not like to sell the computer but would be indifferent to an offer of rupees 3,000. Recently, a government agency invited bid offers for a contract worth a profit of rupees 8,000. Bidding expenses are reimbursable, but the contract materializes and not otherwise. There is an equal chance of winning or losing the bid. After thinking over the possibilities, businessman says that he would be indifferent to submitting a bid at a bidding expense of rupees 2,000. Construct the businessman utility curve by using CME technique.
There are three cases are given for the businessman. Now we will write the different alternatives for each of these three cases. Now for the first case, we can mention here the first alternative as winning rupees 20,000 with 0.5 probability or rupees 0 with 0.5 probability. Now for the second alternative, three preferences according to businessman is mentioned. So first preference, he will prefer return if it is more than or equal to rupees 10,000. Then he is indifferent to return rupees 8,000. And the third one, he will choose the risky alternative for a return less than rupees 6,000. Now if we observe these three preferences, we have to choose the one for the calculation. Now in this case, we will use the certainty monetary equivalent technique, that is CME technique. And for this CME technique, we will use the second preference, that is he is indifferent to return rupees 8,000. Now there are three outcomes. First one will be rupees 20,000, which is maximum, rupees 0 which is minimum, and he is indifferent to rupees 8,000. So this is the third outcome. Now in between these three outcomes, we can write the equation by using CME technique. Now we will move to the second case. So for the second case, minicomputer profit is rupees 8,000, and if he is not using the minicomputer, then there is outcome will be rupees 0, and this profit, that is the gaining profit, is with 0.5 probability, and losing profit is also with 0.5 probability. So we can say that the first alternative is minicomputer profit rupees 8,000 with 0.5 probability, and or rupees 0 with 0.5 probability. Now it is also mentioned that he is indifferent to rupees 3,000 for selling. That means if he will get the rupees 3,000 by selling of minicomputer, then he is indifferent for these two alternatives. That means again for this second case, there are three outcomes: rupees 8,000, then rupees 0, and rupees 3,000. So we can apply here the certainty monetary equivalent technique, that is CME technique. Then again we will move to the third case. So for the third case, here bid offer is there. Now either winning bid offer of rupees 8,000 with 0.5 probability, or losing bid offer at expense rupees 2,000 with 0.5 probability. So when we win this bid offer, we will get the work profit rupees 8,000. But if we lose this bid offer, then what will happen? There are expenses for this offer, and these expenses are rupees 2,000. Now probability of winning or losing is equal. That means we can say that probability of winning is 0.5 and probability of losing is 0.5. So what is the second alternative? So second alternative, that do not accept the offer. That means what will happen here? The outcome will be rupees 0. So in this case also there are three outcomes, rupees 8,000, rupees 2,000. So here we will say rupees minus 2,000 because here expenses are there. And here third outcome will be rupees 0. So again we can apply here the CME technique for this alternative. Now we can assign arbitrary utility values. So for these three cases, if we observe what is the maximum value, so maximum value is 20,000 and minimum value is 0. So we will assign here the utility values, that is U 20,000 is equal to 100. So I will write here it is 20,000, that is equal to 100, and U 0, that is equal to 0. Now if we assign these utility values for the maximum outcome and minimum outcome, now we will apply certainty monetary equivalent technique, that is CME technique. Now we will write the first equation for the first case. Now we will select this indifferent to return 8,000. Because when the person is indifferent, then only we can apply this technique. So how I can write this equation, that is U 8,000 is equal to U 20,000 plus U 20,000 with probability 0.5. So we have to mention that multiplied by 0.5 plus U 0 with probability 0.5. Now we will apply the given utility value. So here U 8,000 is equal to U 20,000, that means 100 into 0.5 plus 0 into 0.5. So 100 into 0.5, that means 50. So we can say that U 8,000 is equal to 50. Now we will move to the second case. Now for the second case also we can apply here CME technique. So I will give the numbers. So this is for first case. Now second case, how I can write the equation. Now the first alternative is 8,000 with 0.5p and 0 with 0.5p, and here he is indifferent to rupees 3,000. So this 3,000 for sure, that is with probability 1 for selling. So I will write here U 3,000 is equal to U 8,000 with 0.5 plus U 0 with 0.5. So U 8,000, that is 50. So 50 into 0.5 plus 0 into 0.5. So 50 into 0.5, that is 25. So we can say that U 3,000 is 25. Now again we will move to the third case. Now for this third case, it is given that there are two alternatives. So winning bid offer 8,000 with 0.5p and losing with 2,000. So we can say that U minus 2,000 with 0.5p. And other alternative, he should not accept the offer. So he is indifferent to accept the offer. So I can write here for the third U 0. So he is not accept the offer, he will get the rupees 0, and it is sure, or we can say certain, with probability 1. So U 0 is equal to U 8,000 into 0.5 plus U minus 2,000. U minus 2,000 into 0.5. Now we will put the value. So U 0. So U 0, that we have already assigned value 0. Is equal to U 8,000. So for this 8,000 we have calculated 50 into 0.5 plus U minus 2,000 into 0.5. So if we calculate this, then we will get, therefore 0 is equal to 50 into 0.5, that is 25, plus u minus 2000 into 0.5. So if we solve this 25 we will transfer to the left hand side and this 0.5 to the denominator. That means this calculation will become minus 25 divided by 0.5. So it will become 250 by 5. So it will become minus 50. So we can say that therefore u minus 2000 is equal to minus 50. Now we will make here one table that will amount, that is M, and utility UM. So when amount is 20,000, utility is 100. When it is 8,000, then it is 50. For 3,025, 0, it is 0. And for minus 2,000, it is minus 50. Now we will plot here one curve. So we know that the utility curve is for UM against M. That is, on this vertical line we have to plot here the utility values, that is 100, 50, 25, 0, minus 50, and on this horizontal line we have to plot here the amount M, that is which is in rupees, 20,000, 8,000, 3,000, 0 and minus 2,000. So we will refer here one particular scale. So on this horizontal line we can take here the distance from this 0, that is 2 centimeter, or we can take 4 centimeter, and we will plot here the value of 4,000. Then again for 4 centimeter here we will plot 8,000, then 12,000, 16,000 and 20,000. In the same way, that is for 4 centimeter the value is 4,000. So for 2,000 value, that is it is minus 2,000. So we have to plot here on the left hand side, we have to take the 2 centimeter distance. Now in the same way on the vertical line also we have to plot the values. So from 0 to 50, if we take here the 4 centimeter, then for 50 to 100 we have to take here again 4 centimeter, because here the equal amount is there, that is 50 utility value. Then for minus 50 also we have to plot here, that is the below this value 0, it is minus 50, and same distance, that is 4 centimeter we have to take. Now if we observe, for minus 2000 value is minus 50. So here we will assign here one point, minus 2000 minus 50. Then for 0 it is 0. So I will write here one point. Then for 3000 it is 25. So for 3000 we can say that from 0 we have to take here the 3 centimeter distance, and for 3000 it is 25. So in between 0 and 50 we will select here one middle point, and if we select here, this will be our point. 8,000 it is 50. So for 8,000 we will assign here 50. So here is 50. And then for 20,000 it is 100. So here is 20,000 and here is 100. So we have to assign here one point. Now we will join all these points. Now if we observe this curve is of third type, that is the businessman is the risk taker.
Now we will read the question, which is based on second method, standard gambling technique. An investor has rupees 10,000 to invest in common stock. His selection is between companies C and D. He feels that for each of the investment he has a 0.7 probability of doubling his money and 0.3 probability of losing half his money, depending upon the company's stock rising or falling respectively. His choices are: first, invest the entire money in either C or D. Second, invest rupees 5,000 in one company and not invest in other. Third, invest rupees 5,000 in C and rupees 5,000 in D. if his utility values for changes in assets are rupees 10,001, rupees 5,000 0.9, rupees 2,500 0.7, rupees 0.4 and minus rupees 2,500 0.2 minus rupees 5,000 0. What investment plan should he choose to maximize his expected utility? Assume that rise or fall of either stock is independent of the other. This question was asked CA Final December 1990.
This question is based on the second method, standard gambling technique. Now we will prepare the table as per the given data. Here different options, so we can say alternatives are given to the businessman, and the alternatives are: first is invest 10,000 in company C, then invest 10,000 in company D, then invest 5,000 in C and not in D, then invest 5,000 in D and not in C, and last option is given, invest 5,000 in C and 5,000 in D. Now we have to select the best alternative by the calculation of expected utility. Now for each of these plans there are possibilities, two possibilities are given. That is, there is the possibility of doubling money as well as possibility of losing money, losing half money. So for the first investment plan, what is the outcome? So we can say that doubling money. So I will just write here doubling money in C, and there is losing half money. So I will write here second possibility is losing half money. Now for this doubling money, probability is mentioned in the question, it is 0.7, and losing half money, probability is mentioned in the question, 0.3. Now for the change in asset values, utility values are provided in the question. So what is the change in asset? So if we observe for the doubling money, that we have invested 10,000 and money is getting doubled. That means change in asset is 10,000 is already there and we will get the extra 10,000. So change in asset is 10,000. Then losing half. Losing half, that means here change in asset is minus 5,000 because we lose the 5,000 rupees. So for losing we will use here the minus sign and we will write here as a minus 5,000. Now we will move to the next investment plan. So invest 10,000 in D. So for company D also same outcome or same possibilities are there, that is doubling and losing half. So these possibilities are given with same probabilities, that is 0.7 and 0.3. So what is the change in asset? That is 10,000, that is doubling money, and losing half, that is minus 5,000. Then invest 5,000 in C and not in D. So only 5,000 rupees we have to invest. So again, for any amount same possibilities are there, doubling and losing half. So for this doubling money, we can say that same probability 0.7 and 0.3. So when the money is doubled, that means this 5,000 will come to the 10,000. So what is the change in asset? That is extra 5,000 are there. So change in asset is 5,000. And losing half. So losing half, that means the 2,500 rupees losing. That means we have to write minus 2,500. Now in the same way, invest 5,000 in D and not in C. So same outcomes are there, that is doubling as well as losing half. So for both companies same probability is given. So we will write the doubling money 0.7 and losing half 0.3. So for doubling we will get extra 5,000, and for losing half this 2,500 rupees is getting decreased, that is minus 2,500. Now invest 5,000 in C and 5,000 in D. So here it is important, when we invest in both companies 5,000, then there are total 4 possibilities. That means doubling in company C and D. So this is the first possibility. So I will write doubling in C and D. Then doubling in C and losing in D, losing half in D. Now in the same way, doubling in D and losing half in C, and then losing half in C and D, losing half in C and D. Now how to write the probability? So when doubling in both C and D, that means 0.7 into 0.7. Then doubling in C and losing half in D. That means doubling is having 0.7 and for losing half is having probability 0.3. Then doubling in D and losing half in C, that is for doubling it is 0.7 into 0.3, and losing half in both the companies C and D, that is 0.3 into 0.3. Now we will write here the change in assets. So here 5,000 is invested and it will become 10,000, and here 5,000 is invested in D and it will become 10,000. So for total 10,000 investment, it will become 20,000. So here change in asset is 10,000. Then doubling in C, that is 5,000, we will get the extra 5,000. But for this 5,000 in D, we lose 2,500. So for losing 2,500, we have to take minus 2,500. So there is doubling in C, that is plus 5,000 minus 2,500. That means here the change in asset is plus 2,500. Now in the same way, doubling in D, that means in company D we will get 5,000 extra, and losing half in C, that means 2,500 we have to subtract. So here also 5,000 minus 2,500, that is plus 2,500, and losing half C and D. So if we observe, when we lose the half in C and D, that is minus 2,500 and minus 2,500, that means it will become minus 5,000. Now utility values are assigned for this change in asset. So for the 10,000 change in asset, utility value is given 1, and for the minus 5,000 it is mentioned as a 0. So we will write here for 10,000 1, minus 5,000 0. For plus 5,000 it is assigned 0.9, and for minus 2,500 it is 0.2. So here also we will write 0.9 and 0.2. Now here for plus 10,000 it is 1, plus 2,500 it is 0.7, plus 2,500 it is 0.7, and for minus 5,000 it is 0. Now we will calculate here the expected utility. Now how to calculate here? So utility value multiplied by probability. So for this first alternative, how to calculate this? So we will calculate this 0.7 into 1. That is equal to 0.7. And here for the second possibility, 0.3 into 0. That is equal to 0. So here this total will become 0.7. Now in the same way, 0.7 into 1, that is equal to 0.7, and 0.3 into 0, that is equal to 0. So here also total 0.7. So here 0.7 into 0.9. So it will become 0.63, and 0.3 into 0.2. That is 0.06, and its total will become 0.69. Now here also 0.7 into 0.9, that is 0.63, and 0.3 into 0.2, that is 0.06. So it will total will become 0.69. Now here also we will calculate. Now it is 0.7 into 0.7, that is 0.49. So 0.49 into 1, that is 0.49. Now here 0.7 into 0.3, that is 0.21 into 0.7. So it will become 1.47. Then here also 0.7 into 0.3, that is 0.21 into 0.7. Here 0.147 and 1, 2, 3, so it is equal to 0.147. Then here 0.3 into 0.3, that means here 0.09 into 0, so it will become 0. Now when we add this, so we will add this, so it will become 0.784. So this is the expected utility. Now we will compare the expected utility for each of the alternative. So for the first alternative, expected utility is 0.7, here also 0.7, it is 0.69, 0.69, and the maximum expected utility is 0.784. So we will select this last alternative, that is the businessman should invest 5,000 in company C and 5,000 in company D.
We will read the question, which is based on third method, logarithmic utility equation. The net return of an opportunity can be rupees 95 with a probability of 0.2, or rupees 15 with a probability of 0.3, or rupees 5 with probability of 0.5. How much would an individual having a utility function of log m plus 5, where m is monetary amount, be willing to pay to buy this opportunity? This question was asked in CA Final May 1990.
This question is based on the third method, that is the logarithmic utility equation. There is the opportunity, and for this opportunity return is rupees 95 with probability 0.2, or we can get rupees 15 with probability 0.3, or we can get rupees 5 with probability 0.5. Now for this given probabilities, what amount that we have to pay, that we have to find out. Now utility equation is also mentioned, um is equal to log of m plus 5, where m is the monetary value. Now in this question there are three monetary values, 95, 15 and 5. Now we will decide person would willing to pay rupees C. That means there are four monetary values, 95, 15, 5, and the value of C that we have to find out. So if we put the first monetary value, that is 95. So utility of 95, u95 is equal to log of 95 plus 5, that is log of 100, and with the help of calculator answer is 2. Then in the same way u15 is equal to log of 20, answer is 1.301, u5 that is log of 10 and answer is 1, and uc that is log of c plus 5. Now these are the opportunities with probability given. So how to find out this? So we can write the equation uc is equal to, now u95 multiplied by probability. So u95 is 2. 2 multiplied by 0.1 plus 0.3 multiplied by 1.301 plus 0.5 multiplied by value 1. So when we calculate this, then we will get the answer 1.2903. But this is the value of utility of C, and utility of C according to this equation, that is log of C plus 5. So we can write here log of c plus 5 is equal to, we will write here 1.2903. So we can take antilog on both sides. So it will become c plus 5 is equal to antilog of 1.2903. So with the help of calculator we can press the shift and log, then we will get the antilog, that is 19.51. So what is the value of c? So value of c is equal to rupees 14.51. So this is the answer.